Hello everyone. What are significant figures? Today we'll be learning that in this video. Okay, so firstly, I'm pretty sure you all are familiarized with the concept of rounding, right? Rounding. So basically, when you round a number, you basically, for example, if I round 178 to the nearest 10, it would be 180, right? Because this is uh this goes up to 180. Right? If it's 174, this is below 5. So it becomes 170. It's pretty easy. Now, I'm pretty sure you all also have heard round it to a certain number of decimal places. Decimal points, sorry. I mean, decimal places, yeah, decimal places, not decimal points. Like, if I wanted to round 28.76 to 1 decimal point, I would have to see this is above, so this changes to 8. This becomes 0. Okay, but of course you don't show it, right? It'll be 28.8. So now you can see there's only one decimal point. But have you ever heard people say, round it to a certain number of significant figures? Aha, significant figures. So, what are significant figures? Now, it's basically just the number of figures that are known with some degree of reliability. So that whenever you measure, whenever you report some measurement, you measure something, it's very important to be honest, so that it does not appear to be more accurate than the equipment that you use, the measurement you see on the equipment. Because you don't want it to be like the equipment says this and you are being dishonest because you show something else. Alright? And we can achieve this by doing something very simple. You control the number of digits. Right? You don't like do this, do that. Just standardize it to a certain number of digits. And in this case, we call it significant figures. Significant figures, which is used like when whenever you're trying to measure something, you round it to report. We're gonna be using SF as the acronym, and I'm pretty sure there's a lot what other people use, alright? They all use SF. Okay, now first and foremost, let me set a ground rule. When I have a number, let's say I have like 68. Oh sorry. Okay, I'm just gonna give you an example. 234 plus 786. What is the answer? It's clearly 1020. Okay, this is a bad example. Let me just. It'll be 1021. Right? Now, is this expression valid? No. This is not valid. This is mathematically incorrect. But here's the thing. When you take 1021 and you round it to 3 significant figures, you go 3 significant figures, it's actually 1020. So how, like, let's say I want my answer to be in 3 significant figures. How am I supposed to express it? If I tell you this, right? If I tell you to do this, but I want you to give me the answer in 3 significant figures, you're gonna get your answer as 1021. But in 3 significant figures, the answer is actually 1020. So do you just put 1020 there? No, because this is mathematically incorrect. You still cannot do that. So instead, what you do is you make it clear. You write this extra thing. 2, 3 significant figures, which is 3 SF. Everyone understand what SF means, so you don't have to worry about like it's universally accepted. So 1020 to 3 SF. This is mathematically correct. I'll mark it correct because it is true. This, if you take this away, it won't make sense. But if you have this, it will make sense. Yes, to 3 significant figures, it is 1020. Another way to do this is use the estimation sign. Now this is equal sign. This is the estimation sign. So if I have this side, that means it's definite. This plus this is definitely this. But the estimation sign is around there when you round, after you round it. You can see the round over here. Okay? So you can also put this, but I usually like to do the first method, which is basically have it as equal sign and then put 2, 3 SF, because it will look more formal and it will be clear like, hey, I am trying to put this to 3 as 7 and people understand. Okay, so now let's really learn what are significant figures. And after we'll learn how to round to a certain number of significant figures. But I think the most important thing is what are exactly significant figures, okay? Now, firstly, this is a rule that we all need to learn. If it's not 0, it is a significant figure. So I'm going to give you guys some questions now. How many significant figures? Okay, sorry. How many significant figures do each of these have? 3, 3, 4. If there is no 0, they are definitely significant figures. That means if that number is a non-zero digit, that means it's something other than 0, it's definitely a significant figure, no matter what it is, where it is. Okay, so I'm going to give you some more examples. Sorry, why's my pen like this? How many significant figures does each of these have? 2, 3, 5, 3, 4. It's pretty easy to understand, right? As long as not 0, it's significant. Even if there's some other stuff like decimal points, it is still counted. That's rule number 1. So today we're gonna be like, gathering some rules, okay? Rule number 1 is non-zero digits are significant. Now, rule number 2. It's a very simple one. Zeros that lie between non-zeros are significant. So, if I have something like 208, this 0 is significant because it's between two other non-significant zeros. Like 64005. These two zeros are significant because it's between. This is actually not between these two. So, let me give you some questions now. I'll just give you a rule and give you some questions. And then lastly, we do a little exercise to test whether you actually understand. Okay. I'll give you a lot of numbers and tell me whether they're significant or not. How many significant numbers we have? Okay. Okay. Tell me. How many? 3, 4, 3, 4, 4, 4, 3, 4, 2. This one is not really related because they are all between non-zeros. Okay. So that's something you must remember. That's rule number 2. Rule number 3 is all zeros at the end of decimals are significant. So if I have something like 6.50, this 0 is significant. Then a lot of you will be like, wait, but a lot of people, at first I also didn't believe this rule. I was like, but isn't this like the exact same as 6.5? Why would this extra 0 make so much difference? Why is it so significant? Because remember, significant figures determine the accuracy, how precise it is. So in this case, this 0 shows the exact accuracy. We have 1 0. Right? Remember, how would I say round? Let's say I have round. Let me think. Round 1.9 to. Sorry, this is a bad example. Round 1.99 to 1 decimal point. What would you have done? You would have said 1.99, right? This is above, so this will go up, but this one will carry 2.0. We have learned this in truncation vs rounding. 2.0. Now, can you express your answer as 2? If I have this question, what will your answer be? Will your answer be 2.0 or will your answer be 2? You may say they are the same thing, but this is actually the correct answer. Why? Because they say 1 dp, exactly 1 dp, so you must follow their rules. Although this is actually the simplified form, but you cannot do that. So, you see why these zeros matter so much. Because it really determines the accuracy. If I have the number 2, and I have number 2.0, I know that this is just a normal 2, this is a 2, a certain decimal to 1 decimal point, which is why it's so necessary to put in 0. Now, you may not really understand the gravity of why these significant figures are so important, why accuracy is so important. But the thing is, the extra zeros over here, the reason for this extra zero is really because of how it is to 1 dp, which is why the zero is necessary. So it defines the accuracy. Sort of, that's sort of how I'm gonna say. It defines the accuracy. Okay. Over here I have 4 examples, quite simple examples. I want you guys to try it out. Pause the video, try it out. Okay, so let's see. 1, 2, 3, 4, 5. Okay, the reason I have these different colors is because it corresponds to the exact rule that it is related to. So if you guys don't understand, you can just look at the colors. So here is 4. Okay, this is interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. There we go. Easy as that. All zeros at the beginning of decimals are not significant. So if I select 0.00004, these zeros are not significant. Let's have a little practice. Practice time. Let's go. In front of decimal. Basically, these are at the beginning. All these rules don't apply because there's no decimals. But in this case, you can see that this is decimal. So you just basically keep putting blues, which is basically not significant, until you reach the part where it's actually non-zero. Okay. So in this case, 1 sig fig. Yeah, this is in between. This is real. This is actually real. This is trailing zeros. So that'll be 1, 2, 3, 4, 5. 5 sig figs. This is pretty easy. I'm not going to say much. 1 sig fig. Okay, these are all useless. Real, trapped in the middle, real. Okay, 4. Beginning, real, trailing. I like how I have just these terms for these, although they are not really called what I'm calling them. Beginning, real, trailing. Beginning, real. Only 1. Okay, okay. Real, trapped in the middle, real, trailing. So it's 4. Real, trapped in the middle, real. So it's also 4. Right. Last rule. Zeros at the end of a whole number may or may not be significant. And you'll be like, wait, what? I'm not joking with you. They may or may not be significant depending on the situation. Now, it's depending exactly, what I'm trying to say is depending on how it was estimated. Now, don't worry, I'll give you a lot of examples so you understand. This is the hardest rule to explain, so listen up. Now, if I just give you, like, for example, a 6,000 without context, it may have just one significant figure, it may have two, it may have three, it may have four. If I just give you a 6,000 without context, so how I would say it, and I'll just say 1, 2, 3, 4. If you ask me how many significant figures, 1, 2, 3, or 4. 1 or 2 or 3 or 4. But this is because there's no context, so there's no way I can exactly know. So if let's say you're asked the question, how many significant figures of 6,000 have without context? It's literally, it can be 1, it can be 2, it can be 3, it can be 4. But if you have context, then you can actually determine it. I'll explain how. Now, if I'm going to just use a 6,000 example. Now, in what situation does it have one significant figure? If I tell you round 5900 to one significant figure. Right? Or it doesn't have to be 00, it could be 59, sorry. It could be like 59, like 13, okay? Doesn't even matter what is over there. This is up. So this will also go up. 6. There you go, 6,000. These are all vaporized into zeros. And they're all not significant, not significant, not significant. Because in this case, the estimation was to round it to one significant figure. This is what was asked in the question, what's the context? One significant figure. So in this case, this was a number that changed into one significant figure. This is how it's done. Alright. Example number 2. This case is to two significant figures. Round 5,984 to two significant figures. So 1, 2. This is the necessary. These are all gonna turn into zeros. Now this is up. So this goes up to the 0. Notice how I differentiated the colors. This is a green, these are orange. Why? Now when I say round 5,984, this turned into a 0, not because it was vaporized. Now I always use the term vaporized, and I love this term. I always use the term vaporized whenever I'm talking about the number turning into 0, because it is being rounded. When I you round this to two significant figures, this is going to be significant, this is going to be significant. These are the two that is going to be significant at the end of the day. These two are just going to be vaporized into 0. So these zeros aren't significant. You get what I'm trying to say? The two numbers over here, they are significant, so they won't be vaporized. These two numbers are going to be vaporized. So you will actually think of it as, but firstly, you must understand what's vaporized lah. Basically, the numbers that will turn into zeros because they are not needed in the entire thing. So in this case, two significant figures, 1, 2. We only need these two. These two no need, so that's why they're vaporized. So you sort of think of it as the numbers that will get vaporized whenever you're estimating are not significant, and the numbers that got turned into a 0 not because they're vaporized are significant. Think of it this way. Now I know it's gonna be confusing, okay, because it's very hard to explain. I don't like explaining this, okay, but you see what happened just now? Right? In just now, that case was, sorry, you had 5984. These two are for sure going to turn into, we're going to be vaporized into two zeros. But this, supposedly, this is just going to go up, and it's going to be 5, like 9 plus 1, which is whatever it is. If it's an 8, it will just become 9. If it's a 7, it will become 8. But in this case, because of 9, you cannot go up anymore because it's the base of 10. So you go up here, it becomes 6. Now this 9 turned into a 0. Now this 0 is significant because this 0 was not vaporized. This 0 instead was turned into a 0 because it 9 turned into a 10. Right? And we use this 0. You know what I'm saying? So this is basically, let's think of this 0 as, if I have 5884, and I tell you to round into two significant figures, you'll get 5900, right? This will plus 1, and you get this. think of it the same way. You have 5, 9, 8 for this time. This one plus 1, and but this time you get a 0. And treat this 0 as any other number. Any other number is also significant. You know what I'm trying to say? Alright, now I want you guys to think of an example for 3 significant figures. Let's see if you understand it. Okay, here's an example for you. This is the easiest example. Alright, this is the easiest example for 3 significant figures. Think about it. 1, 2, 3. This will get vaporized. This is going to be not significant because it's vaporized. These are going to be significant. This is also 0, but this 0 is significant because it is really not a 0 that's being vaporized, just because a 0 that is going to be carried over as a 10. Boom. These 3 are significant, this is not. So this is an example of 3. Now how about 4? You would think that we are already done, right? Wow, how can it possibly have 4? Now this is where decimals come into play. I can have a number like 6,000.3. Or for example 5,999.7, right? This goes down, therefore it will just be 6,000, and all 4 of these are significant. All this goes up, gets vaporized into 0.0, and these are just a result of the rounding. These zeros are just a result of the rounding. Okay, so now this is literally how you differentiate whether it's 2 significant figures, 3 significant figures, or 4 significant figures. It's a very important thing to note. I'm going to recap one more time. Now, if you have a number, I'm just going to use 4-digit numbers. This is the easiest to talk about. I want to round it to 1 significant figure. That means I only need this. Only need this. These are all going to get vaporized into zeros. I only need this. Therefore, this is the only 1 significant figure. To 2 significant figures, 1, 2. These are all going to get vaporized into non-significant zeros. Okay? And this is just going to get into what it's supposed to be like. But in the situation that this becomes a 0 because it gets carried over to whatever it is, then this 0 is still significant. So 2 significance. Boom, 3 significant figures. This vaporized into 0, non-significant. This would basically plus 1, right? It would basically just get to what it's supposed to be like. But then the twist of the century is that it becomes a 0 because it gets carried over. But this 0 is not the kind of normal vaporizing 0. It's the kind of actually become, this is not supposed to become a 0. It's supposed to become a random number, let's say x. Now these zeros are because they are rounded to 0, they are proudly rounded to 0. This is just vaporized. Okay? Last situation. In this case, you have this little decimal. Now this decimal, it's going to become a 0.0 in the end. And because it's being vaporized, it's non-significant. As I usually say, if we have 1.0, this is going to be 2 significant figures because the trailing 0 is significant. But in this case, it won't because it is being rounded. But in usual cases, 1.0, if they don't give you context, then it is significant. But in this case, this being rounded off, so not significant. Now, this will go up. Oh, alright, we'll go up. 0. Now, of course, if it's like 6,000.3, as I gave the example just now, that it won't go up. But I'm just talking about if you have something like 5,999 something, like the examples I gave, because the examples could like vary. These are not vaporized. Yeah, this is 1, but this will be whatever. All in all, rule 5 is the hardest rule because if they give you a random number, you won't be able to tell that some zeros trailing as a whole number. But if they give you the context, then you would be able to tell, and you must determine based on the context, right? Zeros at the end of the whole number may or may not be significant depending on how it was estimated. If it was estimated as 1 significant figure, then the zeros that are part of these significant figures, not 2 significant figures, then it will probably be like something then 0, right? This will be significant. The other ones that are just being vaporized, that are not. So if you look at 6,000, I use 6,000 again. in let's say 1,000, you don't know how many significant figures it has been rounded to this much, this much, this much. If it's rounded to like, let's say 3, then it will be over here, and this one was just being a vaporized zero, but you won't be able to tell because it's hiding. So again, zeros that just are vaporized because they are just like, goodbye, they're not, like, as I said, stop. If 3 significant figures, this one is just the like isolated, ostracized. 2 significant figures, these 2 are ostracized, they are vaporized into zeros. They will always become zeros. You inevitably become zeros. And the ones in front, they will not be zeros. They will just be the ones that will turn into whatever. So guys, always think of it this way. If you have a number, let's say a 4-digit number, you are gonna round it to 2 significant figures. Only 2 would be non-zero. The others will all turn into zeros. But in some special cases, this one will go up to become a 0, right? But then this one will also be significant. So think of it this way, guys. If you have a 4-digit number like so, you want to round it to 2 significant figures. The ones you count 1, 2. Everything after that will just turn into zeros. No matter what, that's a rule of rounding. Everything after the number that you want will all turn into zeros. But the things before will not be zeros. But in special cases where it is 0, it will be significant. Okay. Now, it's time for practice time. I'm just going to give you 10 examples. Okay. But the rule 5 is a bit hard because there's no context. So I won't really give you much rule 5 questions. But if I give you a rule 5 question, then all you need to do is basically just like say this or this or this. Okay. Now, question number 1. Alright, pause the video, try it out. Okay, pause the video, try it out. Okay, you're back. Now I will just basically use my pen. The color, this is rule 1, rule 2, rule 3, rule 4, rule 5. Refer to the list that I gave just now to know which one is rule 1, rule 2, rule 3, rule 4, rule 5, and I'll underline the ones that suit each rule. Okay, so this is the entire thing underlined. Now, I just want you guys to refer to this. It's pretty easy, but there's one that I would like to call out, which is question 8. I think this is a very difficult one that some of you may actually get wrong. Now, the rest I will just hope that you guys know. I'm pretty sure you guys know. You just refer to the corresponding colors. But question 5, I'm gonna call it out. 5,000.0. This is actually a weird one. Okay, now here's the thing. Here's the thing, guys. 5,000 can have 1 significant figure, 2 significant figures, 3 significant figures, or 4 significant figures. But here's the thing. If you look at the colors I coded to 5,000 just now, I gave this, of course, red. I gave these 3 orange, which is actually rule 2, which is captive zeros. That means zeros are captured between 2 non-zeros. And this one, I gave it as a trailing 0, which makes sense. Now, here's the thing. Why does this make sense? 5,000.0. So exactly what's going on here? Now, this number has 5 significant figures. This number has 5 significant figures for sure. Definitely 5 significant figures. But why does this have 5 significant figures? Because remember, these zeros is a bit weird, right? We didn't really agree on the fact that zeros, like at the end of whole numbers, they can be significant or not significant. But in this case, I am just saying that they're all significant, and I'm giving this a rule 2. Why? Not rule 5. Why? Now, here's the reason. Because I'm pretty sure we can all agree that this 0 is definitely significant. So I want you guys to treat it as a non-zero number. Now, you can take my entire video and replace all the things that I said. Whenever I say non-zero, you can replace it with the word significant. So you can take this video and replace all the instances where I said non-zero and replace it with the word significant, and it will still make sense. So in this case, when I said that trapped between two non-zero figures. I also mean trapped between significant figures, because remember, non-zero figures, they are significant. So treat it as I said significant figures. Now, that one was a little mistake of me lah, but technically it is true. Rule 2 states that trapped between two non-zeros. Now, I know this is not a non-zero. This is a zero, right? It's a zero. But here's the thing. It is significant. We can all agree, because it's of rule 3, trailing zeros. We know that it is significant. Therefore, we can sort of treat it like a non-zero figure, which is significant. As I said, you can replace every instance where I said non-zero with the word significant, and yeah, so it also makes sense. So, significant. The things that trapped between will also be significant, and that's rule 2. So in this case, there's a special case. In this case, now if I don't have this will be ambiguous. It may be 1, it may be 2, it may be 3, it may be 4. But with this 0, these are captive, these are trapped, they are rule 2. It's just like saying 5,000.4. 5,000.4. Significant, therefore these are significant. You don't have to like worry about, hey, but this is actually sort of like rule 5, right? You don't have to worry about that. Same thing. I know this is a 0, but don't let it change your opinion that it is still significant. So therefore this stands. So this is the one I like to call out. The rest are pretty easy. Okay, I basically just color coded the respective rules, so you guys can just, pause the video, look back at the different rules and see, okay, this is the rule, this is the rule. I didn't write the number of significant figures each had, okay, but actually it doesn't really matter. I didn't have to write the number of significant figures each number had, because you actually just needed to just refer to the rules, the color coding, and you will know, oh, this is significant, this is not significant, and it's better. You will also know the reason why. Okay, so thank you very much for watching, guys. I hope you liked the video. If you liked it, please like the video, please subscribe, and I'll see you next time. Alright, thank you very much for watching. Alright, if you have any questions, you can drop them down in the comments below, and goodbye. Peace.